Hi, I'll be going over the search insert position problem. So since we have a sorted list, I'm going over the umpire steps. So first we have understand. So for the input, so our input is we're given a sorted array of distinct integers. So I think it means like unique integers. Sorted array of distinct integers and a target value. Our output, so our output is the index. So the index where the target is found, or where it would be if it was inserted in order. So since this is a sorted list, if we don't find the target, we return the index of where it would be if we insert it. And it's a sorted list, so it goes by order. So if we're looking through some examples, if we're given, so yeah, we have nums as our array, so nums, nums equals 1, 3, 5, 6, then target equals 5. We want to return 2, so our output should be 2. So we're looking for 5, so 0, 1, 2. We found in our list, so we return 2. And so nums equals 1, 3, 5, and then 6 again. Our target will be 2. Then we want to output 1. So our output should be 1. So 1, 3, 5, 6. Our target is not in the list, so we want to return where it would be at index 1. So then finally we have 1, 3, 5, 6 again. 1, 3, 5, 6. Our target is 7. Oops, 7. Then our output should be 4. It should be 4, so 1, 3, 5, 6. So we would insert it at the end of the array, and that is index 4. So for some examples, so I think I have seen this problem before, so I have seen similar problems. I'm still learning about binary search, but I have some familiarity with it. So binary search, and then just like in binary search you do start and you get the middle index, so those are things we do be thinking about as well. So umpire, understand, no, this is match. I put examples, but this should be match. And so for the plan, create a start index variable. So we create a starting index variable. We also create a end index variable, and then we loop through the array while start is less than or equal to end. In the loop, we create a middle index variable. So we find the middle index of the array, and then we check if the middle element is equal to target. If it is, we return the middle index. Otherwise we check if the middle element is less than the target. If it is, we update start to be one past the index to be start. Update the start index to be one past the middle. Otherwise, we check if the middle element is greater than the target. If it is, we check if the we update the end index to be one less than the middle index. So we're still working with indexes. Okay, and then since we're going from less than or equal to end, if we don't find our element, so the loop will end if our target is not in the array. So we just want to return start. So return the start index if we don't find if our target is not in the array. Okay. So match plan. So implement. So start. Our starting index is 0. Then end equals len. I believe it's nums minus 1. And then while start is less than or equal to end, we have our middle index, so we find our middle index, so middle equal len nums, or no, oops, it should be start plus end, so we take the start plus the end, our starting plus our end index, and we use integer division to divide it by 2. And then, so if nums middle is equal to our target, we want to return middle. Otherwise, if nums middle is less than target, we want to update start. So start equals middle plus 1. Otherwise, if nums middle is greater than target, then we want our n to equal middle minus 1. And then if we don't find, if our target is not in the array, then we should just return start. And then, yeah, so not hopefully, so our start will update to the index of where it would be if it is inserted in the array, because we're doing less than equals n. So I'll just check it. Yeah, I've got all the test cases, great, and then I'll submit. Nice, so yeah, looks like this solution works. And then we just have one more step of the umpire process, so evaluate. So for space, I'll start with space, it's a little bit easier, I think. I believe it's just O of 1. It's a constant space. We are getting len nums minus 1, but I don't know, I think it's O1. I don't think it's O of n, although we are using len nums minus 1, which will be different depending on the input. So it could be of O of n, but I believe it's O of 1. And then our time, it's O log n. So the amount of time it takes to find the target index does depend on the input of our array, but using this algorithm, we have the amount of elements that we have to look through each time, each iteration of the loop. So overall, this is pretty efficient. And then, yeah, that's my solution for search insert position. Thank you.